Hi everyone, welcome. Sorry, I was just opening up all the necessary things that we need for today's class. Welcome everyone, welcome. Let me get our, opener ready. Y'all are also free to go to Google Classroom and open up today's slides. I believe today is slides day 10. Let me just make sure I go ahead and open those. Slides day 10. Welcome everyone. Last day in the module. But then I know we got like office hours coming up this whole week, which is good. Okay, welcome everyone to AP Calculus here. Last teaching day. I'll go ahead and take attendance once we do our check-in question. I did say, I did also put in here. Not only do you probably want, you're probably going to have a few things open here today. So, have your slides open. They're on Google Classroom, and take the time to also open up your mini final. That would also help you too. So you're not gonna, take the time to do that later. So open up all your stuff. I would also even recommend your big ideas packet as well. So mini final, big ideas packet slides is what you want to have open with you now. So go ahead and prepare that. I know today's a Thursday schedule. There's a lot of people kind of confused right now about that. All right. I hope y'all had the time to go ahead and open up mini final, reread the questions, reread any questions you have. But let us go ahead and do our check-in. So again, welcome. It's March 1st. Our quick check-in today is what's on your mind right now. Go ahead and put that in the chat as I check on who we're missing and who we have. What is on your mind at this moment? It could be about the final. It could be about anything. Okay, finishing my finals. That's being on the mind. That's good. And then having a presentation next class. Oh my gosh. Okay, awesome. Good luck on that presentation. How I need to go to office hours because I don't understand stuff. Okay, that's good. Office hours, awesome. We got sleep on our mind. That's been on my mind too. I keep thinking if I could fit a nap today or not. Redoing my final. I figured out how to solve with derivatives the next day after turning it in. Ooh, someone said they're having some ideas about this mini final. If I'm going to graduate or not because I have bad grades. And I also a presentation I have for advisory. Okay, that's awesome. And yes, you can do it. Don't worry. I'll be here to support you if you need any support for the graduating, but we could do it. I'm thinking about my AP classes. Yeah. Sleep and college. Yep. There's like so many things that would be, yeah. There's also college stuff, portal stuff. There's a lot of stuff happening, right? Just thinking about stuff. Yes. Money and that I need help because I don't really understand it. That's good. That's perfectly fine. And then thinking about that UC admission that's still not here, right? I'm just hoping that's like a delay or something. I have no idea what the UC system is doing at the moment. Okay, y'all, let's see. This is who I oh, and them just being stressed. So being on mind, just having stress. Yep, which is perfectly normal. It's okay to feel some stress. Just make sure you have like something you do when you're stressed, kind of like a routine, something that would help you out in your stress is just a recommendation, but you don't have to. Some people just like to be in the stress and then it passes, or people have different ways of dealing with it. But let me go ahead and let y'all know who we're missing today. We are missing Kaylin with a C. We're missing, I think, also Kaylin with a K. Is that correct? Yeah. We're also missing Kaylin with a K. I am missing, am I also missing Grecia? Yeah, I'm missing Grecia. So that's all that I'm missing. Again, that's 3 folks. Both Kalins are missing and also Brescia. So again, if you're friends with any of these folks, it would totally help. Send them a text to get them to come on into class. All right, y'all. So yes, okay, yeah. So I totally know there's so much on our minds right now, and some of it being stress, some of it being confusion. So hopefully we use this class to the best of the ability today. But don't worry because we have office hours. I am trying to have where tomorrow is just AP Calc. Like I want to just focus on AP Calc office hours tomorrow, and then after that I'll open it up. But we'll see how that works. um, because there's some pre-calc students who might want to jump on in. But so if you plan to come to office hours this week, please come tomorrow. I want to hold the majority of AP Calc tomorrow so we could talk about things that you might still have questions about and also support you in the mini final. Okay, so this is how today's last class is going to run. We had attendance check, cool. We're going to do notice and wonder on number 1 on the mini final. So that means I took a screenshot of someone's work that they submitted and we're going to do a notice and wonder on it. This does not mean that person was like, it does not mean I chose a correct answer. I just chose a sample answer and we're going to take a look at what they did. After that, I'm going to kind of recap what we did in this module and how we should be using the stuff we learned in this module and apply it into our mini final. I'm going to do some modeling. That means I'm going to show you how to kind of get started on number 1 and how to apply your big ideas and collecting of questions. So again, I put a little note down there. Mini final version is due Wednesday. So I put it due Wednesday. Reason for that is I do want to give myself time to grade it. And tomorrow, AP Calculus reserved office hours. We're going to try it. We'll see if it works. And you're coming, right? So I just put that, especially if you're stuck, do make sure that you're coming tomorrow. Otherwise, the office hours for the rest of the week will be open. Like if you want to come in on Wednesday office hours, you could do so. Just keep in mind that I'll be, I think, prioritizing pre-calc, but you could totally come on in and or reach out and make an appointment time with me. There could be some time that I'm not busy in the conference and I could actually help you out. So there's ways to like navigate that. Does anyone have any questions about our agenda today or about what's coming up for us? Okay, no questions. All right, we're gonna go ahead and jump on in to our first line of business. We're gonna do notice and wonder. Again, you want to make sure that you have your resources open, like your mini final, big ideas packet. Just have those open as a tab or something like that. Oh, I guess we're gonna do the recap now. I guess I changed it. Okay, let's do some recap. So what do we do and why, and then we're gonna do the yeah. So I guess I changed this up a bit. So if you're on my slides, it's right there, the link. But this is our running Padlet. Let me go ahead and put this into the chat as well. So what did we do and why? So first off, do refresh yourself on your goals. So you all can read what the goals you set for yourself for this module. So remember, like if the goal was to defend our work, what did you intend to do? Y'all can go ahead and read that. And then we had started off with, I showed you what's something that you might be able to do by the end of the module. One of them is sketching a graph and identifying its key features using calculus. So keep that in mind because that's probably something like if you didn't do in your mini final, how can you push yourself to get there is one thing you want to think about because that's what we've been learning. Another thing we've been learning is kind of like about F double prime. How does it show up? We had a little bit of an investigation question that y'all can see here. We talked a bit about critical points and what they are. So here y'all had some notice and wonders about what critical points are, but then we actually formally learned what are critical points. And here y'all put your thoughts. There are the points where the derivative is 0 or undefined. It helps us determine max and min, perfectly stated. Y'all can read through that. After critical points, we learned about the first, this is actually the steps of the critical points. One thing that came up was there was issues, not issues, but a lot of you were worried about the factoring part, like the part where it got down here where you had to factor and solve for x. That was like a tripping up point when it came to critical points. And then we talked about the different resources there are for us in case that became an issue. So y'all can see that how factoring came up as a problem. But again, we talked about what to do about that. Um, the next thing is we learned about the first derivative test and its sign chart and how it's connected to the original graph. Again, did you use a sign chart in your mini final? Why or why not? Some questions to ask yourself. Ultimately, we've had been learning about concavity of a graph. A lot of you pretty can look at an image and can tell me the concavity pretty well, if it's concave up, concave down. Now, for concavity, that could be something you want to mention if you're striving for advanced. So if you want to talk about anything about the second derivative and concavity, if you want to shoot for advanced, you are open to take that, but you don't have to. That's probably for if you have time to actually address that. After that, right, what we did as a class is we put together all our knowledge that we learned so far to actually sketch a graph. And I walked you through with that. So we actually looked at a function and put the important points as guidelines on our graph, like even inflection points. And this graph that we talked about is actually this one here. So we actually went back to the original function I showed you, but now we had applied calculus to graph it and its key features. So that's what we have been doing. And then we went ahead and we jumped into the mini final. So that's what we did. And now our question is, how do we now apply our knowledge to our mini final? Let's see, there was something in the chat. Oh, thanks, Edgar. You put in the Padlet. Awesome, thank you. Maybe somebody needed it. Thank you so much. All right, so recapping what we did, and now just thinking about how we're going to apply our knowledge in our mini final. Now on the Padlet, which I'm hoping you still have open, and if not, it's on our slide. We're on slide number 5. We're going to do a notice and wonder of a student sample submission for number 1. So we're going to be looking at column number 12. And let's get some credit today, right? If anyone's concerned about any credit or anything like that, let's get some credit. I could input that for today. That way the mini final doesn't weigh down so much, on any scores. So we're on column number 12, y'all. So what I'd like you to do is you actually got to click here to actually see what the student did, and their work is down here. So this is for number 1 only. Go ahead and analyze, what did this student do? What do you notice and wonder? And or what feedback would you give? Those are the things that you could talk about when you're answering or putting your thoughts on column number 12. Let me go ahead and put the directions in the chat. Awesome. I went ahead and put what we're doing right now in the chat. Let me know if you could see it, in case you just came in. Awesome. Yeah. So we're on column number 12. Let me go ahead and make sure everyone has the Padlet once again. Let me put this in the chat. There we go. And again, we're putting either a notice, a wonder, feedback, anything about the student sample piece of work for how they answered number 1. All right, a few of you are still writing down your thoughts. And then we'll come back together once I see we're done with what the student did. All right, a few of you are still completing your thoughts, but I'm going to go ahead and start picking like the common trends I'm seeing as far as notices and wonderings. Most of you are noticing that this student plugged in 14 for W. A lot of you specifically said this student plugged in 14 for the original function. Some of you noticed that the derivative wasn't involved. So it says they didn't solve for the derivative. There was some feedback here. Feedback is to consider the first derivative test and how we used it in the past. So that's some a good feedback there. And then how 14 was the minimum wage number. And then, yeah, so it doesn't seem like they did the first derivative. They noticed that W was 14. And then I think they were supposed to set it equal to 0. And I think that's kind of coming into the first derivative test. The steps are very easy to see. I agree. So the steps are nicely written out. So I wonder why they chose 14, didn't consider first derivative test. Okay, these are great thoughts. Go ahead and finish them up. Let us know if there's any other pieces of feedback, but the most common piece of feedback is first derivative test. Now, let's remember what the first derivative test is and what it helps us find, y'all. So you could, I mean, for this one, you could go back to the slides or big ideas packet. But where is my big ideas packet? Yay, right here. So just make sure you have them open. So I have big ideas packet. I also have the mini final open. So in the big ideas packet, so I'm gonna just click on first derivative test just to remind me. And so what did it do again? It says it tells us about slope, increasing, decreasing, constant, how steep it is, and if it's maximums or minimums. Usually we've been using it for maxes and mins. We have been using it to like kind of like, oh, it increases here, decreases here, but mostly to locate any maximums or minimums on our graph. And there were certain steps to it. So a lot of you are saying like, okay, first derivative test, we could be on the right track there. But why would we use the first derivative test here? What are we looking for? So reread the question. Suppose your goal is to keep as many floor workers as possible employed. Then what is the optimum wage? Justify your decision mathematically. And a lot of you notice that the student plugged in 14, which is basically saying $14 per hour would be the optimum wage to keep as many employees employed, which they got 83.82, or we could round that to 83 employees. That since, we can't have 0.82 of employees would be employed. But let's see if anyone has any ideas, like why would we use the first derivative test here? How would it help us with what we're trying to find in this problem? And again, that's relating back to that. When we go back to the big ideas packet, what does the first derivative kind of tell us? And I'm just giving some wait time to see if anyone has ideas. But if not, don't worry, I'll transition us. Okay, there's an idea there in the direct message. So what the question was, why do you think we need to use the first derivative test for this first question? So here's an answer, and I wish I could copy and paste it. Like it doesn't let me copy and paste people's responses, but let me read it. It can give you the most minimum number that will be the lowest amount of workers you can have is a contribution. So it could give you the most minimum number that will be the lowest amount of worker you can have. So I'm wondering if you're talking about a local minimum or are we talking about a local maximum here that we're looking for in this function. And then we have another direct message saying local max, another one saying local minimum. So we have this either local maximum or local minimum. So if we want to keep as many floor workers as possible employed, is it going to be a maximum or minimum that we're looking for? And then it says local max because we want to keep as many employed. And then we have more who are saying max max into the direct message. Another person said, would it give you the point where the workers are at a max and the pay is at its lowest? It could. Oh, yeah, that's a great answer. Like what if the employers are at the max, but then their pay is pretty poopy? That's actually what this task is gonna, because in the end of this, you're gonna decide. Like, let's say you're a union worker and you want to decide what's best for your union members. That's something you're gonna take into consideration. So I like that you already thought of that. But yeah. So a lot of you said max. There was one person that said min. But let me go ahead and let you all know. Yeah, we want to keep as many floor workers employed. So we want to look for maximums. That's how the first derivative test can be applied here for number one. And it's going to be, I'm going to model it for you. So I'm going to show you kind of how to start on number one, and y'all can ask me questions. So please pay attention. Please make sure you hold on to your questions and ask them, or pause me and ask them, or tell me to slow down. This function's a little bit tricky, y'all. It has decimals. So we got to check our tools. And if we have to factor, we got to know what to do because this looks like it's going to be, that would be very horrible. I don't even want to factor something that looks like this if in case that comes up. So, all right, let's go ahead and get started, y'all. Thank you so much for your ideas, for that engagement there in the chat. Let's go ahead and transition back into our slide. And we are going to go to slide number 6. So I already asked you all this, but this was just in case if it didn't come up here in the chat. But I put, how can we apply the derivative test and our big ideas? So keep that in mind. We have already discussed how the first derivative test can help us because it could tell us a maximum. We want to maximize the number of employees at this superfoods place, right? And then I went ahead and highlighted some developing ideas that this student had. So they said, I tried using the first derivative, but it ended up being negative when I plugged in 14. And then there was like an additional image that showed their calculation, but this student almost did something similar that the sample student did that we all just looked at. So I just highlighted this because I saw some beginnings of thinking about how to use the first derivative. Okay. Okay, y'all. So first off, before we get started, again, I'm going to remind you all of resources to have open, big ideas packet, or any slides that are helpful to you. And the notes we took when we read the mini final is another important resource to have open. So what I mean by that is on your mini final, if you didn't open it before we did this activity, you're able to see all these comments y'all made on this because many of you had the right ideas. Wait, it's loading for me. There we go. That's another thing you want to have open to is the mini final with comments on it. So again, there were some ideas. And there were some that I answered. So for example, this right here, this is going to be our OG function and we have to find the first second derivative, find any concavities. I put yes. I definitely want to see that happen. Again, second derivative tests and stuff, I'm going to leave that for advanced though. And so a lot of like key or tips or hints are given here in the answers. So that's another resource to have open because a lot of you had, good ideas on how to get started. So that's another resource to have open. And right, just making sure you have that open. So again, big ideas packet, your mini final, any slides, and also the notes we took. In addition, at the very top of your mini final, just make sure you pay attention to the direction. So again, in order to at least get proficient, you want to make sure you answer all parts of the questions. Show any of your work, your steps, your thoughts, and why you took certain direction. Try to justify your answers with sentences like, I think my answer is correct, or first I, then I, or use a model, which would be really great if we could actually sketch what this function that they gave us looks like. We could use our derivative tests to help us make a good sketch. Um, so that would be creating a model, and also make some connections to big ideas. Right now, when we're using the first derivative test, that is big idea number 3, I believe. Let's see. Yeah, big idea number 3. That's already making a connection to the big ideas. Okay, so again, please make sure you have your resources open. And let's transition to slide number 8. Okay, so this is what's gonna happen next. I'm gonna model how to problem solve plus apply the big ideas for number 1. Prepare to feel safe, ask questions. Definitely a lot of you felt safe by actually doing a direct message instead of doing an open message. That is totally fine. I do read them out loud just because it will help everyone else. It's very normal to have brain pain right now. So I promise, a brain pain, like your head hurts maybe, or it's like too much, or you feel overwhelmed. So it's normal. So super normal to have that, especially in the AP class, AP math class. And again, learning stance, we're in it, we can do it. So again, I put little things, these are normal. Sometimes it's normal to have little glimmers of hope with frustration and thoughts of giving up. So super normal. I just want to make sure I normalize that. Okay. And then there's some feedback right here in the chat. I think where I messed up is trying to find the first derivative. Yeah, I'm going to help you all find that first derivative here today. So don't worry, y'all. We got this. We just need to know, like, what do we need to solve this problem? How can we apply the big ideas? All the little technical parts, we could figure that out as well together. Okay, let's go. Slide number 9. Oh, okay, I put what the heck did we do? I will apply the first derivative test. I want to maximize the amount of workers. And in this function they gave us, that was called n. It's like n of w. I want to make sure I take into account all the maxima. So maxima is all the maximums. I want to verify, did I take into account all the maximums of this function? And if so, is that going to give me the most employed workers? Also, it's not just me that thought about this, right? I didn't just come in today and be like, you're going to use the first derivative. You all had these ideas. So that's why I put here Edgar and Kaylin had the idea as well. Like, oh, we're going to be using this first derivative test and connections to maxes, mins, even further than that. So I just want to just make sure I highlight that you all had this idea too, and you're like, that you are the holders of knowledge and you all know what to do. So just making sure I bring that back in. This is on the mini final, comments on the mini final. And again, pay attention to any comments I make, because if I'm like, yes, yeah, that's going to be what you want to do. And there's some I said I didn't say yes or something. I probably didn't have time, but if I didn't say no, it's on the right track. Okay. Oh my gosh. So before I actually do this, let me actually hold on. I thought I actually inserted animations, because this looks really confusing if you're just looking at it like this. So give me 1 second, everyone. So make my sign chart. Just gonna do this. Then maybe for those of you who are watching, you could just see like already like a peek on what's happening here. So this. Again, I'm hoping I'm doing this correctly. If not, I mean, we could see. And then we determine maxes and mins at the end. Okay. Yeah, so just disregard that. This is the sign chart. We're gonna see how we got these critical numbers, 58.166 and 141.83. Those are gonna be critical numbers that are gonna happen from the first derivative test. So let me show you how we get there. Again, this is gonna have like funky looking decimals because we had a funky looking decimal type of function. In the real world, when you're modeling kind of real situations like this, you're not going to get nice numbers, and that's why we got decimals. Okay, so first thing I did is first in your mini final, you want to first explain to us, why are we using the first derivative test? And we kind of discussed it a bit already, because we need to maximize or find any maximums of this functions, because we need to find when we're going to have the maximum amount of employees that are employed at this company. So that's why we are doing the first derivative test. So that's, make sure you put your explanation first before you jump in and do the first derivative test for number one. So just make sure you justify why we're using this. Okay, so now let's go ahead and try to apply the first derivative test on this funky looking decimal filled function. So remember, step one is take the derivative. That's when you bring the power down and subtract one. So that's what it looks like. So if I brought this 3 down, I had to do 3 times 0.00014, and I got 0.00112 W squared. 2 times 0.12 is just 0.24. And then the derivative of negative 9.9 W is just going to be minus 9.9. Remember, y'all, the derivative of a constant by itself plus 200 is just 0. So that's why it completely disappeared. So here is the correct derivative in case anyone was struggling with finding the derivative for this function. Let's see, does anyone have questions about the derivative here? Okay, so good. So basically we should all have the first derivative down because, you know, that way you don't have to refine it again. Okay, the next step in the first derivative test, you can look at your big ideas packet, you can look at the slides, but the next step is you set the derivative equal to 0. Somebody mentioned that in today's Padlet too, right? That's the second step in the first derivative test. Just set your derivative equal to 0. Okay. Next step here is going to be, well, what's usually the next step when it comes to this? What do we do next when it's the first derivative test? Let's see if anyone knows. Usually what comes after setting the derivative equal to 0? Yeah, so someone just put there in the chat, usually factoring happens, but yeah, perfect. And I see Edgar in the chat put factor. I had another one, another person just say factor as well in the direct message. That's right, but this looks pretty hideous to factor. I'm not trying to do no box method on that. Too many decimals. So let's use our tool. And the tool, I also linked it down here. Oops, I usually link it in the notes section, but I want to show you where you would find it on your big ideas packet. I'm going to go to big ideas, and I'm actually already on big idea number 3, but the part where I linked about factoring tools is under big idea number 2, under critical points, or, so there's 2 spots. So I put it under big ideas number 2, or if you look down here, tools to find the zeros of a function, you could also click here, and I went ahead and put the tools down here. So the first tool I gave you was Math Papa factoring tool. So this was the very first tool I gave you, and I said, use it, it's gonna help us. So I wanna just show you something. So I'm going to take the thing I'm trying to factor. I'm gonna copy and paste it into the Math Papa calculator. I'm just gonna make sure I put a little, make that a squared. And then I'm gonna put calculated so we could factor it. And then all it tells me right now is there are no like terms. And it says the answer is that. So there is a problem with this calculator. And I think I mentioned this before, but this calculator only does whole, kind of like, it doesn't do decimals. It does kind of ones that have like a nice whole numbers. So this one has come into some issues. So I'm like, okay, so I'm going to give you all another resource. So this Math Papa works only without the decimal numbers, everyone. And I think too, if like we go back, I wish I could show you, but if you go back, like there's a little thing at the bottom of Math Papa that says this only works with like whole numbers or simple functions. So that's not going to work. I went ahead and on the big ideas packet, I linked another calculator that will work. So let me X this out. Oops, let me go back to our big ideas packet. So it says, see, it says only does whole numbers though. So tools that help you check your zeros. It actually gives you the answers for what X is, even if we have decimals involved. I'm gonna go ahead and put this in the chat if y'all wanna play around with this too. I'm gonna be using this though to help us out. So let me click. Okay, so on this one, it's not going to give you the factored form. It's actually just going to already jump and give you these solutions, which is okay. I mean, that's going to be our critical points. Again, if you wanted to factor it, it would be quite a killer. Oops, I'm going to paste my function onto this new calculator. So right here, to make sure this is squared. But if you wanted to know how to get the zeros of this function right here, y'all, if you want to know the traditional way, it would be the quadratic formula. But I'm not going to spend time going over the quadratic formula, so that's why we're going to just use this calculator. If you want to know how to use the quadratic formula to find this, you could check out and review the quadratic formula in the Big Ideas packet. Or if you want to just jump into office hours, I'm happy to show you. So let's go ahead and calculate this. So I put in the function, we calculate it, and it's doing some stuff. Oh, it's down here. There we go. It's so weird. There's too many ads, but it's the other calculator I found. So as y'all can see here, it says the two W solutions, because we're talking about W, not X anymore, is right here. So it already just gives us the critical points. So 58.166, you could round it, and about 141.83. That's how I got those two critical numbers that you see right here on my slide. Right here. So I actually just, oh my goodness. I'm trying to highlight that. There we go. So I actually just used the linked tool. I also linked it right down here. So this is the new tool I'm kind of introducing. Because we have decimals, we had to switch from Math Papa to double check our zeros. Does anyone have any questions about how I got the critical points here? How did I get 58.166 and 141.83? I had to use a tool, but again, if you really wanted to do it yourself, you would have to use quadratic formula to find the zeros of this. Let's see, questions about just the critical number. Then we'll talk about sign chart. Okay, I hope the silence means not confusion and that we get it. I hope like how I got those. And again, I mostly went over how I use that tool, the new tool, and it's linked in our Big Ideas packet. It's also linked at the bottom of the slide. So that's how I got my critical points, due to the fact that I want us to talk about the calculus. I don't want us to review like quadratic formula at this moment. You can use the tool as well in your mini final. Okay. These two things I got solved for. Now notice how I just switched it to X. It's fine, it's because we're just used to the X variable. You keep this as W if you'd like. I just am comfortable with X, so feel free to rewrite it any way you want. So we do have only two critical numbers here. What comes next is you usually go ahead and place your critical numbers on a sign chart, and then you're gonna test. Now we need to check, like for example, we need to check here, are we going to have a local minimum or local maximum? I don't know. That's why we got to test it. And then we got to check this one. Are we going to have a local minimum, local maximum? Keep in mind for number one, we're looking for maximums. That's going to tell us the maximum amount of workers we can hire. Let me clear this. All right, let's go ahead and test. So I'm going to go ahead and start with this first segment here. So that means I have to choose a number that's less than 58.166, and I'm going to plug it into my first derivative. I'm going to check whether or not it's positive or negative. So here's my test. I'm testing x equals 0, plugging it into the first derivative, and I got negative 9.9. So I got negative right here. I'm going to pause for questions, and I see something in the chat. Oh, okay. Someone had an idea to plug in 1. Hey, you could do 1. 1 should still give you a negative. I plugged in 0, y'all, because 0 usually cancels things out, just like it did here. Like all the zeros just made the first two terms go away, and I just got negative 9.9. But 1 is another number you could use for sure. Now, for the middle one, you could already see I got a plus. That's because I'm sorry, but I didn't kind of put my animations in, but let's see why it's a plus. So for this one, you have to choose a number that's between 58.166 and between 141.83. And I believe I just stuck with 59. That's just a number that's a little bit above 58. It's a number between it though. So I chose 59, I plugged it into my derivative, first derivative, and I checked its sign and I got 0.0828. It's a positive number, so I put plus. That's me filling out that sign chart. Again, let me see if anyone has any questions. All right, no questions? Okay, so then now we gotta now test, let's see. When we choose a number to plug in, does it have to be close to it positively or negatively? No, so basically, I don't think it has to be close to it. I just chose it to be close to it because, for example, if I have to pick a number between 58.166 and 141.83, I just think it makes my calculations easier if I choose the smallest number I could choose that's between the two. It wouldn't matter, but you could use any number in between the two numbers or in between wherever your interval's at. Any number will work. That's correct. So we can use any number we want. Yes, as long as it's in between the numbers or in that section. For example, this one doesn't have betweenness. All this had to be is a number that's less than 58.166. And over here, you just got to choose a number that's greater than 141.83. This part right here is any number as long as it's in between the two critical points. So yes. You could choose any number as long as it's between the two or in the interval. That's a good question. So for this last one, I just have to choose a number that's greater than. Oh, okay, actually there's another question. Wait, why does it say n prime of 0 in the second box below 59? Oh, that's because it's a typo. Thank you for that. Look at that, y'all. Plus 1 point on the mini final. Yeah, that's a typo. And the other one has a typo too, so thank you. Great, y'all are making sure I'm using proper notation. Love it. Okay, let me go back to where we were. Thank you so much for that, because that would be confusing if that was, not, if that stayed as 0. Thank you. Yeah, perfect. Any other questions or mistakes that you all can see? Yeah, I usually do the copying and pasting, and again, I think that would happen in pre-calc, and I would always have little mess ups there too. But anyway, okay, so now I'm gonna go ahead and choose a number that's greater than 141.83. Again, because it's gonna make my work and life easier, I choose a number I just choose the next number that's closest to 141, and I think I chose 142. You could choose any number though. Hey, you could choose 1,000, whatever you want. I went ahead and I plugged it into the first derivative test, or the first derivative, not test. plugged it into the first derivative, and y'all, I just use Google, by the way, or just use a calculator or Desmos. I just copy and paste this and it does the calculation for me. But anyways, I got negative 0.0168. So that means I got negative in the sign chart. So there's another question. Also, shouldn't the original function be negative 0.004? Ooh, thank you. Yeah, that is a typo. Oh no, how's that gonna mess up our work? Thank you. I wish you could tell us who you are, but uh-oh. So shouldn't this be this? That is a typo. Now, does that mess up our work though? Is the first derivative still correct? Let's see. I remember that typo, y'all, and I have a little bit of a, I don't know what you call it, but let's see, 3 times 0.0004. The first derivative is still correct, right? It should still be correct. There was a typo in the original. Yeah, so I just checked it. So I did 3 times 0.0004, and I still got 0.00112 here. So I was just concerned that that really messed us all up. No, it should still work. And y'all can double check this, y'all. So 3 times this should give me this. Double check that. Yes, yes, I think so. I'm getting it. Okay, great. We got a student that checked it for us. Thank you so much. I think it's good. Yeah, there was an original typo. Yeah, I don't really talk about this much, but there is this thing called dyscalculia, and sometimes I do mess up my numbers, like the orientation of the numbers, or I think I see a certain number and it's not there. So thank you so much. But there was just a little typo that did not mess up our work. Everything else is still correct. Yay. Okay. There was like an original 1 here. I just deleted it. Okay, y'all. All right, so for the last one, we got a negative, so I go ahead and I put a minus. So according to this sign chart, we have, let me go ahead and draw. We have negative goes to positive. That means right here we have a minimum. But remember, for this problem, we're not really interested in the minimum, but I'm just gonna go ahead and label it. You just wanna make sure that you talk about all your cases. Now for this one, we have positive going into negative, so this is a maximum. That means we're gonna be super interested about whether or not this income, this pay rate, right? If we're right, that's the pay rate, if it's W. So W is the pay per hour. Like I'm interested to know if $141 per hour is going to give us a maximum amount of worker, or a maximum amount of workers, or is it the $14 per hour? Because $14 per hour was also the initial, right? Like it can't go below 14. So that's just something we need to now investigate. So I'm interested in this here maximum. What I'm going to do is now use my first derivative stuff to plot some points on a sketch. That's how I'm now continuing to now apply how we can sketch. And I'm hoping we at least get to this part. And then tomorrow we have office hours so we could continue this with your questions. But I think this should give many of you the tools you need to finish the final though. Okay, let's go on to the next slide. So, yeah. Okay, notes. So again, let's not forget, we need at least, 1 second, not 14 workers. We need at least $14 per hour, 14 minimum wage. And of course, we can't have negative workers. So I just first want you to pay attention to our restrictions of this function. So we're not just going to be checking that maximum value, right, that we just got from the sign chart from the first derivative test, but we need to check the endpoints. So in reality, y'all, I'm actually applying big idea number 3, and number 7. So big idea number 3 was first derivative test. And you should have your big ideas packet open so I can show you big idea number 7. Why is it big idea number 7? Big ideas packet. It's just easier for me to scroll for this one. Look at big idea number 7, everyone. So sometimes an absolute maximum can happen at an endpoint. Sometimes that's going to be the case. For example, in this one, if I did the first derivative test, it gives me this as the local max. But if I was to check the endpoint, the most highest or the most maximum amount of workers in this case would be at the endpoint. So that's what I'm going to check as well. So I'm going to have to also plug in 14 into my original function because they said that we can't pay them less than 14. So that 14 is actually an endpoint, everyone. So that one's actually a little bit of a new one because we haven't checked endpoints yet. Let's see, does anyone have questions before I do this? We're not necessarily checking the endpoint. I'm just going to go ahead and plot these points on a graph and just see which one is higher, which one is going to give me the most workers, at what wage. But shoot, if you get $141 an hour, I don't know, we got to lose some, just kidding. Got to lose some workers to get that high. $14 an hour is not enough in the Bay Area, to be honest, though. But okay, let's go. But you all are going to decide after you do this analysis whether or not, you want to cut a bit of workers for a better livable wage, or if you want to increase the amount of people who are employed. Okay, y'all. So I went ahead and I plotted my points on a graph as the next step. So slide number 12. Now these two things came from my sign chart. This one came from the sign chart, the 58.166. This one also came from my sign chart, 141. This one came from the fact that we need to at least have, we have to pay at least $14 and up. That is an endpoint. Now, I'm pretty sure there's going to be some questions here. So let me pause for questions. So I just graphed my critical points, which are down here. This is an endpoint. Let me label it. Critical point. This is also critical point. In addition, I kind of labeled like where it was decreasing, increasing, and decreasing. This is from my line chart, the increase and decrease portions. All right. There's a question in the chat. Yeah, so that's a good question. Are inflection points related to solving our problem? So let me answer that question honestly. Not in number 1. No, I don't think so. I don't think inflection point will tell me, the maximum amount of workers. Oh, I don't know what. Okay, so for the person that just came in because your Zoom crashed, my bad. So what I just did is I plotted my points. I plotted my 2 critical points first off, right here. These are my 2 critical points from my first derivative test. I, in addition, plotted an endpoint. An endpoint is because the workers have to be at least paid $14 an hour. So it's $14 an hour and up. And I think someone made a comment about that on the mini final. So props to that student, but this is an endpoint. You also have to plot your endpoints. Like, where does my function start as well? We don't know where our function ends, I'll say that. But that might come up once you continue graphing this function. You'll know when it kind of ends, because you can't have a negative amount of workers. So of course it kind of can't go, down here or past it like this point does. By the way, this critical point doesn't really make sense. So if I'm paying $58,166 an hour, I have negative workers. So just so you know, this critical point would have been thrown out if it's in the real world. But so we have this graphed. Now, first I want to ask to see if we have questions though about how I got my points. Yes. So somebody just put this in the chat. Did we use the OG function to find the Y values of 14, 141, and 158? Yes, We used the OG function to find those y values. That means the original function. That is correct. So that was a question. So like, how do we get this? Remember, plug it into the original, not your derivative, original function. That's how we got these y values. That's how I got their like kind of their heights on the graph. Great. Any other questions? Let's see. Now, if there's no questions on how we got the points or anything, I mean, like I said, you are free to make your own sketch as long as you understand how do we get all this stuff. And so actually, it looks like we're gonna have to cut it here, y'all. So I'm hoping that this gives us, those who got a start on this, enough time to finish this up and try to maybe submit something. If not, let's say you still need some more support, come into office hours tomorrow, right after advisory. I hope to see most of you here though. All right, y'all, enjoy because I know you guys got to go to fifth period. Enjoy. Hold on to your questions. Bye, everyone. See ya. I hope it's less confusing. Bye, everyone. Definitely keep my. Yes, you could come to shoot for advanced. Yes. All right. Bye. Bye, everyone.